Hi, welcome to Tech Chain. Today we are going to see few details about address resolution protocol, which is used in layer 2 network data link layer. Yeah. What is ARP? Why we are using it? ARP, which is an address resolution protocol. Why we are using it? We are using to find the MAC address. This is mainly used for the communication purpose, where if you want to communicate one device to another device in a network, you must be aware of the MAC address to communicate. So then, how can I find the MAC address? Suppose you are aware of the IP address, but you are not aware of the MAC address. For that, we are going to use the ARP, which is the address resolution protocol. This is mainly used for the communication purpose. And what it's going to do, it's going to discover the MAC address, which is a physical address, and we can also call it in different names: Ethernet address, hardware address, and which is a 48-bit address. Simple words. In simple words, how we can say? It's going to map the IP address to the MAC address. Means you are aware of this sender MAC address and sender IP address, but you also aware of the destination IP address, which is called as a target IP address, but you are not aware of the MAC address of the destination. So initially, what it do, it considers all zeros and it sends the frame. And at the destination, whomever have this particular target IP address, they are going to respond back with these details: IP address and their MAC address, and also sender's IP address as well as the MAC address. Okay. How ARP packet looks like. As we are aware in the previous uh, session that Ethernet header have destination MAC address and source MAC type. Here we have seen data, padding and CRC. So if we add any header, any protocol information, that is added in the data field as a header. So here we can see ARP header, which is a 28-byte information. In this, we have hardware type, protocol, what kind of a hardware that we are using, whether it is a serial or Ethernet. So type of hardware that we are using, and protocol, what kind of a protocol for the upper layer, like IPv4 or IPv6 or Apple Talk, that it defines the protocol type. Hardware address length, which is a MAC address, we can also call it as Ethernet address. The length of the hardware is 48-bit. Protocol address type, what kind of a protocol? Is it a 4-byte or IPv4 protocol? The length of the IPv4 or IPv6 Apple Talk. Operation code, what kind of operation that we are going to do? In ARP, there are two operations. One is ARP request. We can also call it as ARP discover, and ARP response or as ARP reply. For request, because I am not aware of the MAC address of the destination, so to find the MAC address, what I'm going to do, I'm going to send, I'm going to broadcast my frame within my network. So uh, once it broadcasted, whomever have the destined IP address, they are going to reply back with the ARP reply. So in that operation code, if it is ends with 001, it means that it's ARP request. And if ends with 2, it means that ARP reply. So ARP request always broadcast and response is always unicast. And source protocol address, which is sender's protocol address, because it's a MAC address 48-bit. Target MAC, target protocol address. Okay. And these are the fields in the ARP packet. So as we know, it's a hardware type. If it is the Ethernet, this is the value for the Ethernet 0x0001. And protocol type, for protocol type, if it is the IPv4, it's a 0x0800. And hardware address length, which is a MAC address. So as we know that it's 48-bit address, which if you convert in bytes, it's 6 bytes. And protocol address type. Here we are using IPv4, which is 4 byte, means 4 into 8, 32-bit address. Operation code, as I told, if it is a request, it ends with 001, and reply, it ends with 002. Always request is broadcast, and response is unicast. And source MAC address, as we know, it's a hardware address of the source. And source protocol address, senders protocol IP address. Target MAC address, because we are going to find the target MAC address, it's initially all set to 0 in ARP header, not in ICMP. So I will show you the difference where it's going to set to FFF and it's going to set to 00. If you find the ARP header, there you can see the MAC address field is 00. If ARP packet is not aware of the MAC address, then it all fields are set to 00. And protocol address, receivers IP address. Okay. Here, let's see a scenario. I have 5 PCs which are connected in the bus network, and PC1 want to communicate to PC5. How it going to communicate? PC1 already aware of PC5's IP address, so it will check the MAC address in PC1's ARP cache. If there is no information in the ARP cache, then PC1 is going to send the ARP request to all other devices. In the ARP request, yeah, if you see in Ethernet header, you can see destination MAC as FFFF. And if you see in the ARP header, the destination MAC is set to 000. So what Ethernet header do? It broadcasts to all other port apart from the frame which is received on the particular port. And then ARP header, it's going to be a request, which is the operation code is request, means it ends with 1. And then it sets the destination MAC address as 00. Once it receives back, the reply will be 2. And here you can see the MAC address of the PC5. Yeah. And now let's go and see the actual scenario, how it's going to be work in the packet header. Okay. Let's see a small scenario how PCs are communicating with the ARP protocol by using the source and destination IP addresses. And let's now I'm going to ping from PC0 to PC2. Let's see how it's going to be work. And first we will check the ARP cache. So let's see what is there in the ARP cache. We have only this entry, which is the 10.0.0.3 with the physical MAC address. So the physical MAC address is 00E0. So how long these entries present in the ARP cache? There is a time limit, right? So ARP entries will be available in the table only for 5 minutes, which is 300 seconds. After 300 seconds, all the entries in this table will be deleted. And if you ping, if you want to communicate to the same device, like same IP, again ARP request response takes place to get those entries into the table. Okay, that is the default timer for the ARP entries. Now let me ping, because I already have 10.0.0.3, so I don't want to mess up with the 10.0.0.3. Let's try to ping from PC0 to PC2. Let's see how it's going to be worked. Ping dot 0 dot 0 dot 0 dot 2. Right. So initially, how many packets we can see? There are two packets. One is ICMP and other one is ARP. ICMP works at layer 3, which it communicates with the IP addresses, source IP and destination IP addresses. And if you see the outbound PDU, you will be having only the IP, ICMP, and we don't have any ARP Ethernet headers and all. So if you see ARP protocol, what it will be having, it have layer 2 information, which is the Ethernet header. Initially, what's if we are not aware of the destination IP, what Ethernet header do? It's going to broadcast the packet because I am not aware of my destination IP MAC address. So someone can provide me with the help of MAC address. Just give me a second. Yeah. So now let's see how it's going to be communicated. So what switch to? If you are not aware of the MAC address, it's going to broadcast the packet to all other ports apart from the port which receives the frame. So what information is there? If you see out layer of the Ethernet header, you can see only the MAC address. So destination MAC address it's not aware. That is the reason it kept all yes, which is going to broadcast the frame. If you go inside the Ethernet header, you can see ARP packet. What kind of information? If it ends with 001, the hardware tag means it's an Ethernet. Ethernet cable is connected. It means what kind of a what kind of a cable that we are using. And protocol type, which is we are using the IPv4 address for source and destination. The protocol type is, as we discussed, it's 0x0800. And header length, it's a MAC address. It's 0806, which is a 6-byte field, 48-bit address. And protocol length, it's related to this protocol. For IPv4, it's 0804. And output, as we mentioned, there are two types, ARP request and reply. If it ends with 1, it means that it's ARP request, and response, ARP reply will be 002, ends with 002. And source MAC address we are aware of it. It's 0. I know about my IP address and my MAC address. I am not aware of the destination MAC address. So inside the ARP packet, it keeps the MAC address as 0. If you see outside, it keeps all the values of destination MAC FFF, which means that we are broadcasting the frame to identify the MAC address. But inside the ARP header, it's kept all zeros. Even if you see the outbound, how it's going to send, it's going to send the same information. See what this PC2 do, it discards the packet. And sorry, PC1 discards the packet and PC2 replied back. Sorry, I missed it. Yeah, how it replied? It replied back with, let's see the packet. The ARP code is 0002. 0x002 means it's an ARP reply. So now the source is 10.002 and this PC2 MAC address is 0003. So now it's going to reply. This will act as a source and PC0 act as a destination. So it keeps the destination as a target. Okay. And now let's see what are the entries in the PC0. entries now, 10.0.02 and 10.0.03. Now I am aware of PC2's MAC address. Let's see how it's going to communicate now. Again, can we see the ARP request and reply? Now, if you see only one packet, which is ICMP, and in this we can also see the Ethernet header. Now let's see how we're going to reply. Inbound port, it replied only with the IP address and MAC address. See, we cannot see the ARP here because I am already aware of the destination and source MAC and IP address. Okay, if you see the outbound port also, we cannot see. Now this packet directly requested to PC2 and PC2 is going to reply back. It won't go to switch or PC1. See? Oh, sorry. Yeah. Now, how PC2 replied? It replied with the MAC address. Sorry, it just sent the packet. Okay. This is how the ARP protocol works in layer 2. How the communication happened with the end devices only with the MAC address. Okay. You. Please do like, share and subscribe for more videos. Thank you for watching and we'll see you on next video.